Assalamu alaikum, girls.
Walaikum assalam, miss.
How are you all?
Fine.
Okay. Now, I hope you have the past paper 6 with you again. I want to continue.
Yes,
Very good. That day, yesterday, I was doing 61, May, June 19th. Remember? And we have, yes, and we have finished question number 1 and 2. Now we are supposed to do question number 3. All of you go to page number 8 of 61, May, June 19th. Question number 3.
Excuse me, miss.
Yes.
Miss, you said you would explain me my doubts in atomic physics.
Okay, I can do that. But let us finish this one. What particular topic you have doubts, say?
Miss, it's just the detection of radioactivity.
With the GM counter.
Yes, the GM counter thing. I find difficulty over there.
Okay, and
then it's ionizing effect of different types of radiation.
Okay, this too.
Yes, miss.
Okay, I'll discuss. But let us continue with this question first. After that, we'll give the last 10 minutes for that. Is it okay?
Yes, miss, no problem.
Okay. So all of you go to page number 8 of 61, May, June 19. Question number 3 we were doing. Yesterday we finished question number 2. I want to check with question number 3 now. Okay. All of you see?
The same variant, right?
Yeah, same variant. 61, May, June 19.
61?
Yeah. 61, yes, 61. Okay. Now, look at this. It's a thermal physics question. A student is investigating the rate of cooling of water under different conditions. A greater rate of cooling occurs if there is a greater change in the temperature during the same period of time. So what they showed us, they gave us a thermometer diagram and they're asking what is the temperature. What is the temperature here?
24. Miss, it's 24.
Yeah, it's 24 degrees Celsius. Correct. Now, after that, look what the student is doing. The student pours 200 centimeter cube of hot water into the beaker. She records the temperature theta of the hot water at time t equals to 0, and she immediately starts the stop clock. Fine. Then she continues recording the time and the temperature recording readings every 30 seconds. The readings are given on the table. Okay, now if you just look at it, the student repeats the practical with a metal can. First, he did it with a beaker. Then the student did it with a can. And of course, it's a metal can. A painted matte black in place of a beaker. Okay. So the student used a metal can which is painted matte black. And we got certain results. Now they're asking, the readings are shown on the table. Complete the column heading. I think this one everybody can do. Right, guys? Okay. The column heading will be T in second, theta in degrees Celsius. Right? Okay. Nihat, are you following our class? Is it okay?
Yes, miss.
Okay.
Which rate?
That is beaker and can, table 3.1.
Miss.
Yes, dear. Table 3.2.
Which variant?
I'm doing 61, May, June 19, question number 3.
Miss, Miss, will you mind if I screen share?
You have the question?
Yes.
Okay, then we'll share it, no problem. Let me see the question as well. Others can also understand. Question number 3 of 61, May, June 19.
Miss, can you see?
No, dear, I can't see. Shall I click on share screen or you share it?
No, I'll do it.
Then do it.
Miss, now can you see?
Yeah, now I can see that. Very good. Okay. So, all of you check. I'm checking the readings are shown on the table 3.2. Complete the column heading reading. Look carefully at the readings in table 3.1 and table 3.2. Click the box to show how your conclusion from the readings. What is your conclusion from the reading? So just look at the 3 options that they have given to us. The water in the beaker has a greater rate of cooling. Okay, let's do one thing, girls. To come to the conclusion, we need to know the difference between the initial temperature and the final temperature. All of you do the calculation beside it. Initial and the final temperature. Then we can come to the conclusion. What is the difference you found in beaker and in the can, metal painted can?
Miss, it's the metal can with larger cooling rate.
Okay, but you tell me what is the difference you found initially?
It's 1 degree Celsius.
Okay, so it is not
1
actually
degree
a,
Celsius.
yeah, it is not a significant change. So we can say there is no
Okay.
significant difference between the rates of cooling of water and in the beaker of the can.
So the justification would be the difference is 1 degree Celsius which is
No,
within the
no
limit.
significant difference.
Yes, you have to just mention in the beaker show the calculation and the can show the difference. Then you'll write, so the difference is almost same. So no significant effect. I'm
Okay.
waiting, you complete the answer, no problem. We just mentioned in beaker, you show the difference 94 minus 89, and then can 93 minus 87. You got 6 degree there. So the difference is almost same. So no significant effect. Right, guys? Okay. Now I want you to go to part C of the question. Yes, dear. That is the one. They say a student in another school carries out the experiment and reports that the rate of cooling in the water in the can is different from the rate of cooling of water in the beaker. He plans a change to the experiment to find out whether the difference in the rate of cooling caused by the matte black surface of the can being a better radiator of thermal energy than the shiny surface of the beaker. Okay. Or the metal of the can being a better conductor of thermal energy than the material of the beaker. So, what is the two suitable changes they should do? The student wanted to have this comparison. So, what changes he can bring in this procedure? And the apparatus definitely. Could you suggest me one? Because it has to be
Painting the
Adding a lid.
you can paint
Use of lid.
the
Okay.
Using a lid,
Using a lid.
No, lid will not use here. It has to be in between the can and the beaker. So let's do one thing. Before the the can was painted. Now let us paint the beaker. Use a black painted beaker. And then use a shiny can. Because shiny can and the normal glass beaker will have a comparison. Okay? We are going to paint the beaker with black. So black painted beaker and the black painted can have a comparison. At the same time, we can use a shiny can. Shiny can and the glass beaker can have a comparison. Okay? So write down these two.
All right, miss.
Use a black painted beaker and use a shiny can. Okay. Now I want to go to the next part of the question, that is C2. Suggest two variables that should be kept constant or controlled in order to
it's volume of water.
And
then the size of the beaker. Initial
Why size
temperature
of the
water.
beaker?
no, it has nothing to do with the beaker. It has to be room
So
temperature.
it's initial temperature of water.
Initial temperature, equal volume of water, room temperature. These are the things that has to be controlled.
Miss, could you repeat the one, like C1?
Okay, C1 was use a black painted beaker or use a painted beaker and use a shiny can. And use a shiny can. Okay? Okay, now listen guys. I think we don't need the screen right now. Okay, now I want you to complete the last part of the question. One precaution that you take in order
Using
to...
a sensitive thermometer.
No. Did you notice accurate thermometer reading? So temperature reading. How
Avoid
you get
parallax error.
thermometer.
Avoid parallax error.
Yes.
Parallax error.
Yes, but you not just mention the word parallax error, you have to explain it.
Eyeline perpendicular.
Perpendicular to
Yes.
the readings to avoid parallax error.
Yes, that can be the correct answer. Yes, that is the one. Done. So now girls, look at the planning question of number 4. I think I did it with you in the class. Do you remember?
No, miss.
Yes, miss.
No,
I did it.
Yeah, we did it
I
in the
didn't.
class.
When?
I didn't get this. When did you
And
do
we
it?
Anika
haven't
used to
done
stay
this.
absent most of the time.
Yes, in the class.
Not
Actually,
really.
I did it. Yes, yes. Do one thing.
I was not absent in any of the physics class, to be honest.
Okay, fine. Listen, Noreen, could you just switch off the screen share now?
Okay, miss.
Okay. Yeah, done. So now listen to me, guys. Who didn't solve this question? Is it
Me,
Anika?
miss.
Okay. So Anika, do
I
one
did
thing.
not.
Yeah, listen to me. Do one thing. You do it at home and send it to me in my WhatsApp. I will check and inform you what are the mistakes there. Okay?
All right, miss.
Yeah, fine. Good. Now I want to go
Miss,
to,
can I even? I think I was absent.
yeah, you can do the same, no problem here. Okay. Is that Sanjida? I have noticed. Sanjida, how are you? Sanjida, how are you?
Yes, miss.
I think last
Fine,
class.
alhamdulillah.
Yeah, that's good.
Fine,
Good.
alhamdulillah. Miss, how are you?
Alhamdulillah, I'm fine. Good to hear from you. Okay, now let's go to 62 May June 19. Okay, listen, guys. Those who listen, yeah, listen to me one thing, guys. Those who did not complete the previous planning question, you do it yourself and send me in my WhatsApp. I will check and inform you about your doubt, about your mistakes and all. Okay, so let's go to 62 May to 19, and I want you to start doing question number 1. All of you read it. It's about that moment question, the pivot and the meter rule balancing question. So all of you read it and then let's start doing it.
Miss, I hate these questions.
Don't say like that. You have to do it. And it's easy.
They are very hard.
You hate it, but it was not a very fun.
We can't avoid it.
What
yeah?
are we doing?
62 May June 19, question number 1.
Miss,
Okay.
do I share again?
Yeah, you can. But I think
Please
everybody, yeah, everybody's having that variant. Yeah, fine.
I don't.
I don't have the variant as well.
It's okay. Now you can see this question we are doing now.
Balance.
Okay, now all of you check it. They say a student is investigating moments using a balancing method. They gave us the apparatus diagram, and if we just look at it, the student places the meter rule without the load and the pivot and adjusts its position. Okay, so that the meter rule is as near as possible to being balanced. She keeps the rule at this position on the pivot throughout the experiment. So the pivot position is not changing. Fine. Explain briefly why this position on the pivot may not be exactly at the 50 centimeter mark of the rule. Okay, so girls, who can say what's the idea about it?
Miss, I want to say,
Say, sure, I could hear you.
because the meter rule is not exactly 100 centimeter.
No, dear, I don't think so. It is at 100 centimeters because it's a meter rule.
No.
The center. Miss, how about the objects on the P and Q? It's hard to determine the exact.
No. It's about the
might be at a different place.
50 centimeter is not the center.
Yes, you have to mention that the center of mass of the meter rule might not be at 50 centimeter mark. Might not be. Because all the time we do expect that at 50 centimeter mark, it will be the center of mass. But it's not necessary. It might not be, because the center of mass depends on the width of the particular meter rule, right? So it might not be uniform all through the meter rule. Okay. Now let's go for the part B of the question. They have given us a table by measuring A and B, and they told us to draw a graph. Okay. Is there anyone who has already finished the graph?
Yes, miss.
Okay. Could you tell me what is the pattern of the graph that you found there?
It's a straight line almost going through the origin.
Yes, and did you notice it's clearly written? Start both axes at the origin. We cannot start it from any other place. Yes. So you got a straight line from the origin. Is it or not from the origin?
It didn't exactly go to the origin.
Origin. Yes. Actually,
It's
it will not
near.
go. Yes, yes. And it will not go there. If you check part C, what is the answer of C that is you found there G?
0.9.
Yeah, okay, that is correct. And did you notice at D there's a question, determine the intercept C on the x-axis. So now we understood why our graph did not go to the origin. There is an intercept in the x-axis. So what is that value that you found? A?
1.
Intercept? No. I'm talking about D. Means C. C is the intercept of the x-axis. How much you got there? You got it.
Can you repeat?
Part D of the question I'm asking you here. Determine the intercept C on the x-axis of the graph.
Yes, but see, part D I got 1.
Okay. You got 1. Okay, fine. No problem. Let's see. I got it 2. Okay, no problem because it can vary. It depends on. Now, you tell me one thing, Adina. Did you trace the last point, last dotted point, and the first dotted point, and then view the line?
Yes, miss.
Okay. Then it's supposed to be close, like 1.9.
Miss, I got 3.5. Miss,
3.5 would be too much here.
I,
It has to be around 2. I got it as 2. So just take it again after talking, after my class, take it again. Now look at it. Part B of the question they told us that you have to measure the width of the load P have given us a diagram. So how much you got there? W equals
2.3.
Yeah, correct. 2.3 centimeters. Now, all of you turn the page. Let's go to the question number 1F. Yes. Okay. They're asking, another student suggests that the value of C, means the x-intercept, should be equal to half the width of the load P, means W, whatever you got W, half of W should be equal to C. So, Adina, whatever answer that you have found for the C, do you think it matched with this?
No.
Okay.
Well, it does.
Okay, so I found myself the statement as no, because my justification was C, I got 2, and W by 2, I got 1.15 only. And the difference is kind of 0.85, which is large and beyond the limit of experimental accuracy.
Miss, my difference came 0.1.
Then also,
is it okay?
it is big. No, it is also big. If you find out the percentage error, you will find out it will be more than 10%, I think. Just check it. Do it like this, 0.15 divided by 1, that was your value, 1 multiplied by 100, check what's the answer coming out?
15.
15%. So definitely it's no, it's large and beyond the limit of experimental accuracy. Okay, and the rest of you who didn't do it, I think you have to draw the graph first, then only you'll come to the conclusion of this answer. But it will be definitely no. The difference will be really high, and that will be beyond the limit of experimental accuracy. Okay, now, part G. Suggest one practical reason why it is difficult to obtain accurate value for A and B.
Difficulty in balancing the load on the meter.
Alexa,
I think that is the correct answer. And you'll remember, girls, whenever we have a pivot question like this is the common practical reason that gives us a wrong value. That is difficulty in achieving exact balance of the rule on the pivot. Because the pivot is a sharp edge, the rule keeps on slipping off. That is why we cannot find out the exact position where it actually got balanced. Okay, the one we always...
Miss, could you repeat?
Difficulty in achieving exact balance of the rule on the pivot. I hope you have finished that question. Okay. Now,
Miss, could you repeat G?
G. Difficulty in achieving exact balance of the rule on the pivot. Difficulty in achieving exact balance of the rule on the pivot. Okay. Now let's go to question number 2. It is a thermal physics question. All of you read out the question, then it will be easy. A student is investigating the rate of cooling of water under different conditions. A greater rate of cooling is there, occurs if there is a greater change in the temperature during the same period of time. They have used two different procedures. Once they are using a lid on the top of the beaker, later they are using an insulating mat at the on the top of the table, right, at the beaker. Right? That is the difference between the two experiments. Okay. So first, check what is the temperature of the room they found.
The temperature is 23.
22.
22.
Yeah, it is 22.
22 degrees Celsius.
Yes, fine. So after that, just check like this. They did the practical 2 times. One time with the lid, one time the beaker was on the mat, and they found 2 tables. From there, they're asking us to come to a conclusion. Okay, this question is kind of very similar to the one that we had in the 61 variant. Right, girls? Yes. So just check what is the difference coming out for both the cases.
Yes, the difference is same. There is no significant difference.
Actually, we got this one. Okay, 5 and the 6. So again, the same thing. There is no significant difference between the lid and the mat in reducing the rate of cooling of water. Okay.
Yes, miss.
Okay. So the justification we can write just like before. With lid, the temperature drop is 5 degrees Celsius, and beaker on a mat 6 degrees Celsius. So no significant difference. Okay. Now I want to check part C of the question. All of you check. It is written. Yes.
Question 2B3.
Okay, you can write it there. That's, yeah. With lid, temperature drop is means beaker with the lid, or in beaker A, temperature drop is 5 degrees Celsius. So the difference 81. Yes, dear. With or you can write in beaker A, the temperature drop is 81 minus 76 equals to 5 degrees Celsius, and in beaker B, 83 minus 77 6 degrees Celsius. So no significant difference. Okay.
Okay, ma'am.
Fine. Now let's go to part C. A student plans to repeat the experiment using the same apparatus and the same volume of water. Suggest one change to the procedure that will decrease the rate of cooling of the water. Rate of cooling of the water. Okay. So you tell me what they can do that will decrease the rate of cooling. What we can do that will release the or reduce the decrease.
So we can use insulation.
Yeah, you can do that. We can go for
As per
that.
Sanjida said.
Okay, thus
Keeping
yes.
the temperature outside the beaker same.
Did
And
Nurin
maintaining the
say what you want to write down there? 1 minute, 1 minute. I think we can better go for an insulation because we want to stop the rate of cooling. So definitely insulation will be a good choice, and we didn't have the insulation till now, so we should have it. Okay, fine. Now part D. Take one precaution that you must take in order to record accurate temperature reading. I think the same one. You have to keep your eye line perpendicular to the reading.
Avoid parallax
error. Okay, fine. That's good. Now let's move to the next question. E.
initial
repeat D?
temperature and volume of water? Initial temperature and volume of water.
D.
D is the same thing. Keep your eye line perpendicular to the temperature reading to avoid the parallax error. Okay. Okay, then they say it is important to view a measuring cylinder correctly to obtain the accurate value of the volume of a liquid. I think this one everybody can do. Which box will you take?
Scale should be good. Right angle parallel to the scale.
No. Right angles to the
Why
scale.
not?
Right angles.
Why, miss?
Because it's a parallel spiral. We have to avoid that. Right angles.
Okay.
Now, all of you turn the
Yeah,
page.
it says perpendicular, right?
Okay, you go to.
Miss, it should be right angle to the scale.
Yes. Right angle to the scale.
Hazina, what is
Okay.
wrong with this?
Okay, now all of you.
I'm really sorry. It's just not
Okay.
me. I hope we are in the class. Really.
Okay, now listen. Let's go to question number 3. All of you check question number 3. Okay, there we have, it's an electrical current electricity question. All of you check it carefully. Write down the readings shown on the meters on the following diagram. So, someone tell me what is the voltmeter reading?
Oh, it
3.6
is
3.6.
3.6.
But don't forget
and
volt.
0.3.
In both the cases, you have to
0.3.
write down the unit. Without the unit, you will not get marked. So
3.6
and
volt
0.4
and
volt
0.
and 0.3 ampere.
yes, that is
volt ampere.
3.6 volt and 0.3 ampere. Okay.
Ampere.
Now, yes, part B of the question check. You have to just place both the values and get the answer. What is the answer? How much you got for R1? R1 equals to? Yes, girls. Did you substitute the values of V1 and I1?
Miss, 12 ohm.
Yes, 12 ohm. That is correct. R1 equals to 12 ohm. Now, part C of the question, the student connects the voltmeter across the lamp L. Okay. Now they have shifted it from the resistor T to L. Then what happened over there? They found it, the values they have given to us, that the voltage reading, and it's a series connection, so current will remain the same. If you substitute 2.4 divided by 0.3, check how much you got there?
8.
8 ohm. Okay, fine. So R2 we got 8 ohm. Now the student replaces the resistor P with another resistor Q. P is not there. He placed another one, that is Q. She records the potential difference V3 across Q and he found some reading. And after that,
11.3.
yeah, you did the calculation? Fine. So it's 11.3 ohm. Okay. Now let us read, yes, ohm. Let's go for D2. They say, take whether the results R1 and R3 suggest that resistor P and Q have the same value of resistance within the limit of experimental accuracy. Justify your answer. Justify your statement by the reference to your result. Okay. R1 was 12 ohm and R3 is 11.3. So do you think the difference is kind of large? Okay, someone find out the percentage.
And beyond the experimental.
Yes, but someone find out the percentage. 0.7 divided by 12 multiplied by 100.
Miss, could you explain it
No,
again?
it's 5.8%.
5.8. But
Yes.
that's also more than 5%. So it is beyond the limit of experimental accuracy. Okay.
Oh, so we take percentage only till 5%.
Yes. So the statement will be no, and the justification. Then justification we can add R1 is 12 ohm, R3 is 11.3. The difference is 0.7, which is large and beyond the limit of experimental accuracy. Okay. Okay. Now go to part E of the question. The student connects the voltmeter across the lamp L. Okay. And then he says she records the potential difference V4, that is 2.5, and the resistance is R4, 8.5. She suggests that the change in resistance of the lamp from part C is due to a change in temperature of the lamp filament. Okay, suggest an observation that she could make to confirm that the temperature of the lamp filament changes. Now, look at that. It is actually a theoretical question. In theory, we discuss about it. How will you understand the temperature of the lamp gets changed? First, by looking at the lamp, how will you understand?
Brightness.
By its brightness.
Yeah, you can say that. We can check the brightness of the lamp because the more the temperature means the higher the temperature of the lamp,
The more the brightness.
the more the brightness. So you can just write down brightness of the lamp changes. If it increases, then the temperature increased. So brightness of the lamp changes. Okay. Now complete the circuit diagram to show that the two resistors and the lamps are all connected in parallel. Okay, the voltmeter is connected to measure the potential difference across the resistors and the lamp together. Okay, state the name of the circuit component that you would add.
A variable resistor.
Okay, fine. So I'll just give you a few minutes. Roughly, you just draw the diagram.
Variable resistor.
So roughly, you just draw the diagram.
All right.
Okay, roughly you draw the diagram and tell me, is it clear for you? Did you understand? Okay. They said
yes, miss.
Listen. You have to understand that here the lamp and the two resistors are connected in parallel. And then you have to draw the voltmeter across all of them.
Parallel to the circuit.
Yes, yes. And then you are going to have the rheostat or the variable resistor in series with them. Okay? Oh, now listen to me, guys. Let's go to the next question. That is actually a planning question. And it is a lens question. I remember this question actually I think I have given to you in midterm. Do you remember this? This question we had in our midterm.
This question?
Yes, the planning question that I am discussing with you now. It was in our midterm. So,
did we do this as well?
Since I think this one I haven't discussed with you in the class, so I will just read out.
Why don't you remember anything?
No, listen to me. I'll be reading out the whole procedure. I want you to listen and you can take a short note about it and complete the question and send it to me in my WhatsApp. I will correct and give you the feedback. Okay? Now, listen. In this question, they're asking us that we have to find out the relationship between the thickness of the lens and its focal length. Thickness and the focal length. So, if we just look at the diagram, they have given us an equation. So, that equation will give us to find out F. F means the focal length of the lens, and we are going to measure the thickness, and then we will have a comparison. So, you have to draw a diagram. And how will you draw the diagram? We'll draw a scale, and on the top of the scale, you draw the lens. That's the way it is given on the question paper. And then two wooden blocks will be beside it. With the help of the two wooden blocks, we are going to measure the thickness. And we'll say that we have a reading R1 and R2. Assalamu alaikum, girls.
Assalamu alaikum, miss.
Wa alaikum salam.
Assalamu alaikum.
How are you?
Fine, alhamdulillah.
Now, today I will be continuing paper 6. The question I was doing with you yesterday, that was 63 May, June 19, right? But before that, as Anika was telling yesterday that she's having some doubt in radioactivity. So the first half an hour, I want to discuss about radioactivity. Is it okay with you girls?
Yes.
Okay, fine. Could you hear me, girls, loud and clear?
Yes, miss.
Okay, good.
Yes, miss.
Yeah. Anika, I remember you told me that you have a doubt regarding the detection of radioactivity, right?
Yes, miss. Yes, miss.
Okay, fine. So, to know that one, before that, I need to just tell you a small thing about ionization or ionizing effect. So, in ionizing effect, we discussed that when a radioactive material or a radiation passes through a gas, you remember this is a particular way of ionizing a gas molecule, especially when actually before that we need to remember what is an atom. An atom consists of proton, neutron and electron.
Electrons.
Proton, yes. Proton, proton and neutron stays within the nucleus and electrons are roaming outside in the particular permitted shell, right guys? So,
Yes, miss.
yes. So, when an atom actually loses an electron or gains an electron, it becomes an ion.
Ion.
Yes. So, nuclear radiation, actually, any nuclear radiation means it can be alpha, beta, or gamma, when it passes through a gas, that time some of the molecules are going to lose electron. Then that particular atom will turn into an ion.
Do they always lose electron?
They will be losing. I'll come to that details discussion afterwards. But first, right now, you'll be remembering that they are going to lose it initially. And after losing, that particular atom will turn into a positive ion, and the electrons which are coming out, they will act like a negative ion. Okay. So this property of the radiation is actually used to detect the radioactivity. Means we need a certain device, the one we call it GMQ, that was invented by two scientists, Giger and Mueller. They invented this tube. And what is that tube? A Giger-Mueller tube is a small closed glass tube with a thin mica end window. Okay. Now, girls, do you remember what was the mica that I have discussed with you? Do you remember that?
Yes, mica is
A very good conductor of electricity.
Yeah.
Yes, it is actually a crystal which is formed, which is turned into a thin sheet. And that sheet is actually a very good conducting material of electricity. So with that, they're giving one side a window through that the radiation will get inside the GM2. And there is a central wire which is acting like a anode. The inside of the tube is coated with a conductor. Mostly we use any metal. Here they do use aluminum for giving a coating. That coated aluminum coating that is given inside the tube will be acting like a cathode. And we have a PD. We are going to apply a PD which will be around 450 volt and in between the anode and cathode. When we are applying this PD, then we are going to experience some changes over there. What are those? If you just look at the diagram that I have given to you regarding the Giger-Mueller tube, you can clearly see we place some argon gas, and even it is mentioned it has to be low pressure gas. Okay, now if I say low pressure,
why do we get the argon gas again?
We are giving the argon gas because the ionization will happen in the argon gas molecule. When the radiation will get inside, the argon gas molecules will turn into, or the atoms will turn into ion. That will give us a signal that will be seen in the scalar. Okay. So what is happening?
Miss, argon can only lose electron because it has full outer shell.
Yes.
It cannot gain.
Yes. And you'll see afterwards that whenever radiation comes across any gas atom, they are going to actually lose the electron all the time. They will never gain the electron. I'll come to that point, but let us finish this part first of all. I told you that these are accident. Okay. Before that, when radiation enters a GM tube, it creates argon ions and electrons by collision with the argon atom. Means even if I pass alpha or beta, it is going to have a collision with the argon atom, and the argon atom itself will become an argon ion and electrons will come out. These are accelerated towards the electrode and cause more ionization by colliding with the other argon atoms. On reaching the electrodes, the ion produces a current pulse. Now, pulse means one single wave. So, whenever an electron and a positive atom, means the one we call positive ion now, they are going to create a pulse which is a single wave of electricity that will be counted by the scalar. The scalar meter is, or the scalar or the rate meter is connected outside the this GM tube. There we can find out how many radiation, means how many particles, whether it is alpha or beta, got inside and how many atoms got ionized. That reading will get here. Means one alpha particle is going inside, it will create one atom. So there will be a pulse. One ion it will create, and there will be a pulse. Like this, we can count how many alpha or beta particles got inside. Is it clear to you now? Anika?
Miss, I'm not understanding. I'm missing out. Like, okay, after the argon gas becomes ions, what happens next?
These two means it has a positive ion and a negative ion. Together they will go to the scalar and they'll create an electric pulse, because a positive and a negative can create a pulse. You know that.
Yes.
One single wave will be created, and we can see there's a count. One number will come out. See, think about one thing. So that pulse is created by one alpha particle. So we can count, okay, there's an alpha particle. Okay. So like that, the next topic, if you just look, we had a topic, detection of alpha, beta, and gamma.
Yes, miss.
Yes. Do you have any doubt in this place?
No, there it's clear. I just found it like I got confusion with the cube,
Okay,
the GM
fine.
cube.
So is it clear now? Means actually the radiation is getting inside and having a friction or a collision with the argon gas and argon gas molecules. Molecules, atoms, all are there. So after having the collision, these argon molecules or argon gas atoms are going to lose electron. And when they lose electron, they will turn into a positive ion, and that electron will become a negative ion. And together they will reach the scalar and create one electrical pulse. And that will be a count there. Okay? Now, let's go for the other topic that you have mentioned there. That is ionizing effect of different types of radiation. Isn't it?
Yes, miss.
Okay.
Yes.
Yes, it is very much related to this topic, the one we discussed right now, because there we are using the ionizing effect, but how the effect is happening due to different type of radiation, we can come to discuss, we can come to know from this particular
Miss,
topic.
may I ask one question?
Sure.
Miss, you said that like in ionizing effect, atoms usually lose ions, but in the
Yes.
definition you gave, it says lose and gain. Why is that, miss?
Exactly, I'll tell you. Actually, any atom can lose or gain, because one of the electron that is coming out from an atom has to go somewhere, isn't it? So it will go
Yes.
to the other electron, another atom, and replace or knock out one of the electron from that and take its place. So isn't it gaining, losing, gaining at the same time is
So
happening?
it's so miss, it's anyway gonna get full outer shell or something?
No, 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 no. It can never get full outer shell. Whatever it was
So
there before,
one will have more, one will have less.
yes, definitely. Then it will become a negative ion, isn't it? If it is more negative ion. Okay, now let's come to that point.
So miss, when it happens with argon gas, like for example, you said in argon gas, the gas will lose one electron. Where will that electron go and collect? Because all our argon gases, all of them have.
They will, listen to me here, they will not go anywhere. They will keep on roaming around, because they will create, one electron is coming out, means it is a negative ion now. It became a negative ion. So that negative ion and the positive ion that is created by it, they together will go and create a pulse. Positive and negative? Yes. Okay. Now, come to
They have nothing to do with they have nothing to do with other argon atoms. They'll just go and create a pulse.
Yes, yes. Okay. When alpha particles pass through a gas, they attract electrons away from the gas atoms due to their relatively large mass and +2 charge, and causes ionization. We know that what is alpha particle actually? It is nothing but a helium nucleus. It has two positive charge, that is due to the protons that is inside the nucleus, and it has two more neutrons. Together it becomes four nucleon inside the nucleus. So due to the charge of the two protons, it has a habit of taking away or knocking off 2 electrons from any of the atoms which it comes across. Okay, so definitely when two electrons are coming out, that particular atom will turn into a positive charge. So we are saying, and it has another point, that alpha particle do have a huge mass. If you look at the comparison that I have given to you due to the mass, so alpha particle has huge mass, and that mass actually allows it, and due to the +2 charge also, it allows it to have the largest to show the largest ionizing effect. Okay, now if you come to beta, beta is actually nothing but an electron. Okay, now I can see Mehreen joined us. Mehreen, do you remember how do we actually get the beta particle from a nucleus? Do you remember, Mehreen? Could you answer me?
No.
Okay, then I can ask who else? Noreen, could you answer the question? Yes, Noreen?
Yes, what is the question again?
Yeah, question is that how do we actually get the beta particle? Means that is nothing but an electron, we know that, but how we get that one from a nucleus where they're not supposed to be any electron?
When a nucleus it breaks down, it emits alpha, beta, and gamma.
Yeah, I know that. But inside the nucleus, we do have proton and neutron. But beta particle is actually an electron. Then how come the electron is coming out from the nucleus?
Because because the neutron breaks down into a proton and electron.
Okay. And then what happens to the proton?
The proton stays in the nucleus, and the electrons it goes out as beta.
Very good. Yeah, that's the correct answer. So now we are discussing about the beta particle. When the beta particle passes to a neutral gas atoms, now beta particle itself is negative. So what will happen? When it passes to the neutral gas atoms, it will repel the electrons out. Before alpha particle was attracting the electrons out, now beta particle is going to repel the electrons, making them positively charged. So these electrons they're taking out, they become, the rest of the atom is getting positively charged ion. After that, gamma, as we know that gamma don't have any charge, it's an electromagnetic wave. So it cannot show,
Miss,
yes.
I didn't get the point what Noreen was saying. Like, how does beta particle come out of nucleus? What is it again?
Okay, inside the nucleus we have proton and neutron. A neutron is going to break up or break itself into a proton and an electron. Then the proton stays back inside the nucleus, the electron comes out in terms of beta particle. Otherwise, there's no chance that we can have an electron inside the nucleus. It's impossible. But the neutron breaks itself. Okay, that's why.
So does alpha particle has this same thing? Like
no.
Only beta particle shows this.
Yes, alpha particle has a different behavior. Alpha particle comes out in terms of 2 proton and 2 neutron together to alpha form. So it has nothing to do with breaking up of a neutron or anything. But beta particle comes out when a neutron breaks itself into a proton and an electron. Proton stays back, electron comes out in terms of a beta particle. Okay. So this beta particle, since it is having its own charge as negative, it will knock out, means with a strong repulsive force, it will knock out the electron from the nucleus. And then, from the atom, not from the nucleus, from the atom. So the rest of the atom is actually turning into a positively charged ion. And as I came to gamma ray is that it has no charge, it has very less mass. In fact, we call it gamma particle is having 0 mass. Then also, just due to its high speed, gamma particle do show secondary ionization. Means at some point in some particular gas, gamma particles do knock out some of the electrons due to its high speed. That time we can see some secondary ionization. Means some of the gas atom will turn into an ion that time, but it is not a regular one. That is why we say gamma particle shows weak ionizing effect. Okay, not a strong ionizing effect. Strong ionizing effect is shown by alpha particle, and then we have the other one, beta particle is showing ionizing effect less than alpha but more than beta, more than gamma. Gamma shows the least ionizing effect. Okay, now if we just look at the last thing that I wrote in my note, I wrote it, the detached electrons from the above cases, means alpha and beta and gamma, gets attracted to other neutral atom forming negatively charged ion. Sometimes it also happens like that, because just imagine a gas atom we have which is having in outer shell only 1 electron. So there are room, right, for the other electrons. So it can attract one of the electrons to get inside, and it will turn itself into a negatively charged ion of some other element, some other gas it will turn into. But then also it will become attached. Okay.
I didn't understand.
Listen to me. You know that every element do have their electronic structure. Right?
Yes, miss.
Like 2, 8, 8 like that. So think about, we are using a gas which is having in its outer shell as 1 electron only on the second shell. So we know that it has room for 7 more electrons. So there is a chance that the detached electron, the ones which came out due to the action of alpha and beta and gamma, that electron can easily go and join that atom and turn into a new gas.
Yes.
Yes, a new configuration, and they will become a negatively charged ion. Okay, so like this, we have the positive and the negative ion that is created by the alpha, beta, and gamma when it is passing.
So why do they become negatively charged then?
Listen, that particular atom has certain number of proton initially. Now 1 electron joined. So what happened? Now electron number got increased. It will be definitely a negatively charged ion. What else? Because proton was less, isn't
Yes.
it? Now the proton number became less than before. Okay, fine.
Yes.
Now you tell me, do you have any other doubt regarding this topic?
No, ma'am.
No, miss.
Okay, is there anyone else have any doubt regarding radioactivity topics I want to discuss today? As we have time. Anyone?
Miss,
Mm-hmm.
the half-life calculations.
Okay, now, okay, since you say, let us go for those half-life calculations, because we have two type of calculation. First of all, you
Yes.
remember when you just go to the laboratory and you just switch on the GM counter, immediately we'll get a count without keeping the source in front of the GM tube. Why? Because we know that
That's the
in our
background radiation.
yes, background radiation in our environment, there are certain sources which can provide radiation, and that can be counted by the GM counter initially, the moment we switch it on. Okay. There are possible sources of the background radiation. We say that it can be cosmic ray, it can be the building
Granite rock,
materials, granite rock,
soil,
or it can
air.
be, yes, soil, air, earth, even food, drink, anything. Okay, so when we are going to switch on the GM counter, we got a count. And we're saying it is actually nothing but the background radiation. Okay, fine. After that, when you are placing the radioactive source in front of the GM counter, you will see that the count is will suddenly rise a huge amount. Okay, think about it was initially 20, suddenly it went to 400. So if you just think about the first count you got on the first reading, you got 400. So we say a BG correction means if you subtract 20 from 400, that will give you 380. That is the real count by the source that you have placed in front of the GM counter. So that is the real count. Do remember that. That is the real count. But if you don't subtract, that one will be the reading with the background. So in our exam paper, in some of the cases, they do give us the real count. Sometimes they give us the counts with the background. Okay, there can be two questions. Sometimes they give us a reading, they will give us 4 or 5 readings, which is actually nothing but the background radiation. So what we have to do, we have to take an average to get the background radiation. So after getting the average, then you will be checking what is the count is coming on the scaler. They will give you, think about they gave you 300, like before I told you, or 400 they gave you. And the average of the BG count, you got 20. So you'll subtract 400 minus 20, 380 is your real count. Now this 380 you'll be dividing by 2. 380 divided by 2, so you got right 190 something. And then when you want to find out this half-life from the graph, you have to make sure that you are adding that 20 one more time. Because after dividing by 2, you got the real count, okay? Not the count with the BG. So you have to add BG along with it. Then you go to the graph and find out the corresponding value in the x-axis. Because in the x-axis, all the time we place the, all the time we use the time, that is day, that can be in day, in hour, or anything. In minute also it can be. It depends on the particular source. Okay. So is it
Can we repeat the graph again? What do we do?
okay? I'll tell you again. Listen to me. As we said that first your 400 was the count reading they gave us, just an example, and 20 was the BG count. So you have to subtract first. So 380 you found. Then you divide it with 2. You have to divide this one by 2 because half-life we're discussing. And what is the formula for half-life? It is the amount of time taken for a radioactive substance to become half of its original value. So 380 was our original value. We'll be dividing by 2. And then we got the reading 190, 19 to the 38, I think yes, 190. That is the real count. But when we are finding out the half-life from the curve, the graph they have given to us, we have to add 20 along with that. Okay, after adding 20 with 190, it became 210. Then from the graph, you check where is your 210. Then in the y-axis, definitely you'll find out 210.
X-axis.
And then to the corresponding x-axis, that is the time shown, will be the half-life of your radioactive element.
Yes.
Excuse me, miss.
Yes.
There was this question when they said that find the half-life after 10 days. So do I have to like divide by 2?
Yes, yes. You have to keep on dividing by 2 until you reach the final count, the one they have mentioned. Okay, then if it was 10 day, think about you got 5 times half-life. So 10 divided by 5, 2 days. Got it?
Okay.
Fine. So I hope it is clear to you now.
Yes, miss.
Okay, fine. Anyone else have any doubt regarding this particular calculations? Okay, one more calculation I need to mention, girls. There is certain question they are asking number of decayed atoms. So whenever we divide by 2, we actually find out the rest of the atoms left with us. Okay, we always find out when you divide, means when you're dividing by 2 gradually, the number we are ending with, that is the number which is left to decay. But if they ask me that you have to show the number of atoms which has already decayed.
Original number minus what we have left.
Exactly. That one you have to remember. But here we have to show the subtraction. The one I'm left with, we have to remember that when we are finding out the number of decayed atoms, that time after doing this calculation by dividing by 2 consecutive 3-4 times, the number of atoms that is in our hand, we are going to get it. And then how many actually, think about, you started with 5,000 atoms. And after doing 3-4 times of half-life, you are having in your hand now only 500 atoms. So the question was that how many atoms got decayed? So you'll subtract and find out. It is just like that question. Think about, you went for shopping with 500. Yes, and you came back at home and you have only 20 real in your bag. So how much you actually spent? You subtract and get it. Isn't it? Similar type of calculation. Fine. Now, any other doubt girls you have here?
Miss, I find problem like when they give in a table, like a big table, and they give counts 0, 0, and then 19, and then it keeps increasing. So in that case, how do I find out the half-life?
Okay, then when it is 0, 0, that time you remember they didn't have any source in front of it. And in those type of tables, they will give us initially, or they have to mention initially the background means background radiation count they will mention initially. So you'll just check at which particular time they have placed the source and then started, the count started going up, or it will start rising. From that point, the point where it started rising, you'll subtract 20, and that will be your real count, 20 or whatever, they'll mention the BG count. And after knowing it, you will divide by 2 and then check. Think about, after dividing, you got 400. Then you'll check on the table, where is that 400? Is it there somewhere? You might not get it 400, you might get it 420. Why? Because 20 background radiation you have to add with it again. The moment you'll get, or means after how many blocks, they will give us according to the time, like every 5 minutes, every 1 hour, like this, right? So how many hours later you got 420, that value you'll take, and then that is your half-life.
Okay, Miss.
Okay, fine. So I think
Miss, I'll do some calculations and then send you. Could you please check it for me?
Yeah, sure. Send it, and you have to be patient because that paper sheets also I didn't check. Inshallah, tomorrow I'll check.
Oh no, it's fine, Miss. Like anytime you get, but I'll just do when I get time. I'll send you.
That is
that
good.
would
That
clear
is
my.
Yeah, no problem. That is okay. You just send it, and whenever I'm done with it, I'll just send you the message on WhatsApp. No problem. Okay.
All right.
So yeah. So guys, I think we can switch off the discussion of atomic physics now. Shall we move to paper 6? If you don't have any other doubts, shall I do that?
No. Yes, yes, Miss.
Okay, now let's go to the variant I was doing with you. That was 63, May, June 19. And I think we were supposed to do question number 2. Girls,
yes, Miss.
Yeah, fine. I hope all of you are having that variant in front of you.
Yes, I am having it.
Okay. And it was a question regarding thermal physics. And first of all, if you just look at the diagram, they have given us a tube and a beaker. Test tube and a glass beaker, and inside the test tube we have the boiling water.
Miss, which year are we doing?
63, May, June 19.
Miss
63.
63, May, June 19, question number 2. Yesterday I did question number 1. Question number 1 we did. Question number 2 we couldn't do. Now I want you to go to B2 part question. B1 we wrote the temperature was showing
21 degrees Celsius.
21 degrees Celsius. Okay. Now, if you look at B2, they told us again that one, you have to check the reading after every 30 seconds. Describe briefly a technique that would ensure the temperature reading are as accurate as possible in the experiment. Okay. The same point we can write again, girls, regarding keep your eye line of eyesight at the level of the thermometer scale. Right? That point we can write again. Similar thing. Because we want to avoid the parallax error. So for that, we have to ensure that our eye line is perpendicular to the beam. Okay? Now, let's take the next part of the question. Part C, they say, write a conclusion stating how the difference in temperature.
Excuse me, miss.
Yes.
I'm sorry I missed B2 because of internet connection problem.
Okay, it is actually nothing but that one we wrote about, like keeping your line of eyesight perpendicular to the thermometer scale. Okay.
All right, miss.
Okay. Now, let's take part C. This is here that write a conclusion stating how the difference in temperature between the cold water and the hot water affects the rate of heating of the water in the boiling tube. Okay. Now, actually, what was the practical there? We kept, if you just look at the diagram, there was a thermometer inside a boiling tube, and there was a beaker where we had the hot water, and we kept the inside the boiling tube there was some water, and we kept that tube inside the glass beaker, and we checked the temperature change there. And every 30 seconds we saw that the temperature was actually increasing. If you just look at it, in the boiling tube it was 31 degrees Celsius, and in the beaker it was 83, like that. The temperature in the boiling tube got increased, and the temperature of the water in the beaker got decreased. If you just look at the last part, that was 63 and 73, and the difference was 10 degrees only. So we have to justify our answer by reference to the readings. Means we are going to check the reading, and then we'll find out actually how this pattern of change occurred. If you just look at the table, initially I wrote greater temperature difference causes greater rate of heating. Means if you look at initial position, 52 degrees Celsius increase was there, difference was there. So we wrote at the beginning, 30-second time, rise in temperature is 52. But at the end, when it was 150, there we found the temperature difference is only 15 degrees. Means the transfer thermal energy got decreased. When the temperature difference between the two liquids got is having less difference in between them. Isn't it? Okay. So you can conclude, you can show that the greater temperature difference causes greater rate of heating. This is the bottom line of this answer. Means the more the temperature difference between the two liquids will be causing greater rate of heating. And then
This is the bottom line, miss?
Yes. Because 2 mark, then we have to refer to the diagram. Sorry, to the table. You can say after that at the beginning, means at 30-second time, you can write at 30-second time, rise in temperature is 52 degrees. If you just look at the 4th column of the table, you can understand 52 degrees. But at the end, what happened? On the 50th second, it became only 15 degrees Celsius.
But in the end?
But at the end, on the 150th second, or you can write 180th second also, no problem. 180th second, look at the table. It was a temperature difference of 15 degrees, 10 degrees only. Okay, only 10 degrees. Okay, fine.
So, and in 182nd, the temperature difference was only 10 degrees.
Yes, yes. Okay. Now, I think we are done with this particular question. Do we have any other part of this? Okay. Okay. Yes,
Yes, I'm sorry, could you repeat that? The greater the
temperature difference, the greater the rate of heating.
Okay.
The greater the rate of heating. Okay. Now they told us in part D, there are 2 parts of the question, D1 and 2. In 1, they're asking, state what you expect the temperature in the boiling tube will be when theta C stops rising. Justify your answer by reference to the reading. Okay. Now theta C. Theta C means which one? Look at the diagram. Theta C is 63. Right? The last point we found in the boiling tube. Right?
Yes, miss.
Yes. So now they're asking, what is your idea that how high this temperature could be? Because already you have noticed that the temperature difference is now 10 degrees Celsius. So it can be just an assumption we can draw. Just a guess, wild guess. If it is 63, it might go highest to 65 because the temperature difference is very low. When it is low,
Yes,
the heat transfer will be really, really less. So we can just write down statement 65 degrees Celsius.
65 degrees Celsius. And what should be the justification, Miss?
Yes, we have to mention it. As the water in the beaker reaches,
Sorry, Miss?
as the water in the beaker reaches a lower temperature, as the water in the beaker reaches a lower temperature. Okay, you can write down the temperature 73 degrees because it was on the table, it is mentioned. Bracket 73 degrees Celsius, close the bracket. So the temperature in the boiling tube will not rise significantly. So the temperature in the boiling tube will not rise significantly.
Okay.
Fine. Now I have to go to part 2 of the question, that is D2. Say what you predict the temperature theta H of the water in the beaker will be after few hours. Now I want you to give me the answer, girl. You think about.
Miss, would that be an assumption as well?
Yes, but that
Then around 49 degrees Celsius.
You're very wrong here. Listen to my point first. Whenever think about you took or you made some coffee and kept it on the table, you did not drink the coffee.
It will be room temperature.
Exactly, Ajina. That's the correct answer. Because it will keep on decreasing the temperature and come to the level of the room temperature. It cannot go down below room temperature. But it has
So
to
37.
be 37. The room temperature was 21, I think. Initially, we
okay.
wrote it. Yeah. You can write 21, 22. Both can be the correct answer. But it can never be more than that. Okay.
Miss, can't it be 23?
Yeah, it can be, but it has to be close to the room temperature. Don't go a bit higher also, not that much higher, not even 25. Because if it is 25, there's a difference between the room temperature and the liquid. They said after few hours. Did you notice that? Few hours. So they have given us enough time to cool the liquid down. So we can write 21 degrees Celsius to be on the safe side because that is the room temperature. Clear, guys? Oh,
Yes, Miss.
fine. Now check E. Suggest 2 changes that could be made to the apparatus or the procedure to ensure that the temperature theta C of the cold water in the boiling tube rises more quickly.
More volume of water, Miss?
Less volume of water.
Okay. In fact, you know, the answer both of you have given both are right, but it has to be together. Means increase the volume of hot water, which was in the beaker, and decrease the volume of cold water that is inside the boiling tube.
Oh, okay.
Got it? So together you gave me the correct answer. But we have to mention both of them. Okay, it will be in point number 1. Increase volume of hot water and decrease volume of cold water. Clear?
Yes, Miss.
Okay. Now let's go to E2. So what we can write about this particular point?
Can we talk about thermometer or something?
Not really. We can discuss
For
about
this
the
second point, we can say higher initial temperature.
of which one here?
Miss, you're saying about E, right?
Yes, E2. So higher initial
So higher
temperature.
initial temperature of the hot water
Okay.
and lower initial temperature of the cold water.
Yeah, very good answer. Yes, that can be done because there has to be a huge difference between the two liquid temperature. Temperature of the two liquids, then only the heat transfer will be moved. So we can write increase the temperature of hot water, initial temperature of hot water, and decrease the initial temperature of cold water. Okay, both the way it will be correct. You can write the way Adina said that higher initial temperature of hot water and lower initial temperature of cold water. That can also be written.
Okay.
Okay. Now I think we have to go to question number 3. All of you take question number 3.
Miss, is it decreased temperature of hot water or increased temperature for hot water?
Increased temperature of hot water, decreased temperature of cold water. Okay, so that we can have.
Could you please repeat D1?
Okay, D1 was that we are going to increase the volume of hot water, decrease the volume of cold water. More hot water, less cold water.
D1 that that predicted temperature when theta C
Oh,
stops rising.
yes, yes. I gave it as 65 because 63 was already on the table. So a little bit more heat transfer will be there. We were expecting like that. So it can go to 64. Okay, so I just increased 2 degrees and then showed that as the water in the beaker reaches a lower temperature, 73 degrees Celsius, so the temperature in the boiling tube will not rise significantly. Okay, because they have a difference of 10 degrees only. Okay.
Okay.
Okay. Now, shall I go to question number 3? If you're done with 2, then I can move to question number 3. Yes, are you done with that?
Yes, miss.
Okay, fine. Now, question number 3, it's the current electricity question. So, I want you to check. They say on the figure 3.1, draw the symbol of a voltmeter connected to measure the potential difference V across the resistor X. Okay, girls. So I think you can do this one across X. So you can just draw the voltmeter symbol across this X resistor. Not all of them, only X. Remember in the question it is mentioned.
Done.
Okay? Very good. So let's go for the next part. Here they said a student connects the voltmeter as described in A and measures the current I in the circuit and the potential difference V across resistor X. And they have given us the two diagram of ammeter and voltmeter. You have to read out. So
it's 0.22 for the ammeter and 1.1 for the voltmeter.
yeah, I think it's right. Yes, 1.1 for the voltmeter. Okay, now the rest of the values are given on the table. You have to just do the calculation. Could you do it quickly if it is not done? If it is done, then we can just check. But I want you to do it now so that we can have the
Miss
next
5.24
Mm-hmm.
and 14.35 and 23.81.
Okay, 5.24 is the first one.
Yes, miss.
Okay, fine. And then what is the next one?
14.35
Okay. Let me see here. We are having it. Mhm.
and then 23.81.
Yeah, 23.81. I think it is correct. Okay. After that, this is you have to complete the column heading as well. Did you complete that?
Yes. It's
Okay.
A, V, and O.
Okay, guys. This program is going to shut down within a minute, but just wait. I'll give you the next. Hello, guys. Welcome back. Okay. Now, guys, let's start again. So I was checking the table 3.1. Yes, right, girls? I hope by the time you have finished the calculations and we got 3 values for R. And I hope you have completed the column heading. It will be I will be A, that is ampere. Voltage will be volt, V. And then we have resistance, that will be ohm. Right, girls?
Yes, miss.
Okay, fine. Now, just check this. In C, it says a student suggests that the current should remain constant when the voltmeter is used to measure potential difference across the different combinations of resistors. State whether the readings support this one. If you just look at the diagram, if you look at the table, could you just say what will be the statement? They said the current should be the same. Yeah, it will be yes, because look at the readings that we got 0.
Close.
Very close, in fact. 0.22, 0.23, 0.21. Okay, fine. So the statement will be yes. Justification, you can just write down I equals all the values. So that 0.22, 0.23, 0.21, and then you can write down the conclusion. The values are close and within the limit of experimental accuracy. Okay, guys?
Yes, miss.
Okay, fine. Now, I want you to check D1. Calculate and record in table 3.1. Oh, already we did this one, isn't it?
Yes, miss.
Yeah, we did it. Okay, now we should go to D2. 4 resistors in series, the total resistance of the combination is the sum of the individual resistors.
Excuse me, miss.
Yes, yes.
Miss, I missed C. 3C.
Okay. The statement is yes. Quickly do it.
Miss, what's the justification?
Justification is that we'll be writing I equals, write down the 3 values on the table. I equals 0.22 ampere, comma, 0.23 ampere, comma, 0.21 ampere. Write down and wait.
Yes, miss.
Yes. After that, put a comma. The values are close and within the limit of experimental accuracy.
Close.
Yeah. The values are close and within the limit of experimental accuracy. Then D1 already we did because we have completed the table. There we mentioned the values that we found. We already wrote it. Now come to
Yeah, that's
D.
just a calculation. It's fine.
Yes, yes, yes. You can show the calculation over there. Okay, now D2, they say for resistors in series, they gave us the idea that it will be just the addition. We know that when it is a series connection, all the resistors are going to be added. Use your result from the table 3.1 to calculate the resistance Ry and Rz of resistors Y and Z. Okay. Now, if you just look at it, X and Y together is giving us 14.35. So I can just subtract from the X and get the value of Y. Isn't it, girls?
Yes, miss.
Yes. So Ry equals to 14.35 minus 5 point something. And then Rz will be 23.8, the last one, minus the second one.
Okay.
Fine. So you might get the values like 9.35 ohm or 9.45 ohm. Okay?
Yes, miss.
Now you go to part E, that is on page 10, E1. Okay. They have given us some informations or some conditions. We have to draw a circuit. First, note down the first condition they told us is that resistors X, Y, and Z are in parallel. Okay, so you'll be drawing 3 resistors in parallel, and the 2 common points will go to the emitter, and then to the switch, and then to the source. Isn't it?
Yes.
Yes.
Okay. Excuse me, who's that? Could you switch off the microphone for you? Yes, that's better. Okay. Now, then the next one they say the voltmeter will measure the PD across all the resistors. Okay, fine. So it will be just among the 2 common points that we have across the 3 resistors. Right, guys?
Yes, miss.
Okay, done. Now you go to E2. Part E2. One student sets up the circuit as described in E1. Means that student had already set up the circuit and now he is doing the practical. After doing the practical, they found Rp equals to 2.31 ohm. Already all given in the first paper. Use the student's result and your result from table 3.1 to compare Rp, that is in parallel, with the resistance Rs that was in series. Means there we found all the 3 connected in series and the value was 23.8. So we have to find a relationship between these 2 and put a tick on these few options that they have given to us. So just check, that time it was 23.8 and now we got 2.31.
RP equals 10 RS.
Are you sure?
It's 10 RP.
No, it's 10
No,
RP.
the third one is the answer.
Yes.
Third
Third
10
one is
RP
the
equals RS.
exactly. The third one is
Yes.
the correct answer. 10 Rp equals to
10
R.
RP equals RS.
Yes, very good. Now it's done. Okay. Now we have question number 4. I think if you remember this question,
Miss, we
we
did that
did it in the
already.
class. Exactly.
Yes, miss.
Ball bounces.
Yes, yes, fine. So I think we can proceed to 61 October, November 19. Okay, then
61.
October, November 19.
I'll take time to download. Miss, could you please wait 2 minutes?
Okay. By the time I want to talk to you, girls, listen. as this week we did mostly the paper 6 question, and we have three classes a week. So I'm thinking, so next week let's do one thing. Let's go to paper 4 of 2019. By the time you might, by the time you have finished, I know. So we can have a comparison. We can discuss if you have any doubt in any particular answer that you didn't understand how to get it. So next week, inshallah, we'll go for 41, 42, 43 of May, June, and October, November of 2019, all the papers. Okay, fine?
All right.
Okay, that's
Miss, 61 October number?
2019. Okay. Now, let's see. Yes, the first question is regarding that balancing a meter rule on a pivot. Okay, all of you go to that page number 2 of 61 October, November.
Is this 1 more minute? Hold on.
Yes, I'm here. Wait. Find that.
Done.
Okay. Now, question number 1. All of you check. We have a question regarding that balancing question of a meter rule on a pivot.
Yes, miss.
Fine. Now, okay, in A, they have given us the idea about how they do the practical and all. Let's go to A1. Calculate and record in table 1.1 the distance B between the center of the load P and the pivot. Okay. And it has
Miss,
to say.
I got 16.9 for B, and A divided by B is 1.37.
Okay. Yes. Okay. Now, here's the twist in the question. Adina, could you tell me how did you get actually 16.9?
Because of subtracting.
Yes, that is the twist. Otherwise, if we just measure, first of all, did you notice that where did they actually place the pivot?
Yes, miss.
What is your idea about placing the pivot?
That's the center of mass.
No, not the center of mass. Did you notice there's a 50 centimeter mark?
It's
On the
somewhere
diagram?
else.
No,
Like
look at,
this.
yes. The pivot is not at 50 centimeter mark. And did
Yes.
you notice that they placed P, means the block they wrote it to 90 centimeter mark.
Yes, miss.
So if we just look at the table, A is given 23.1, isn't it?
Yes, miss.
Okay. So it means that if I want to find out B, I have to first, what I have to do? B will be
Measure.
No. You don't need to measure
No.
from there. It has to be calculation. It's written clearly that
Okay.
you calculate from the table, from the diagram.
40 minus 23.1.
Yes. Means first of all, 90 came for the P, position of P, minus 50. 90 minus 50. And from there, you subtract again 23.1. Because we don't know the position of the pivot. So to know
Yes,
the
miss.
position of the pivot, we have to do, like, you can just write down the short calculation beside your table. B equals to 90 minus 50 minus 23.1.
Okay.
Then it came out as 16.9. And then A by B, you can just do it yourself. Not a problem.
Okay.
Yes. After that, they say you have to plot a graph of weight of load P against A by B in the Excel.
Which one we are doing?
61 October, November 19, question number 1.
Miss, could you repeat it?
61 October, November 19.
Thank you. Question number 1.
Miss, can I ask where did you get the 23.1?
Okay. I told you, do the calculation like this. B, they told us to find out B by calculation, not by measuring. So B equals to, just first write down, B equals to 90 minus 50 minus 23.1.
Yes.
Okay, now you just look at the diagram, you'll understand. P is kept at 90 centimeter mark, isn't it? It's written on the diagram. Got it?
Yes.
Yes, and there they say there's
Yes,
a 50 centimeter mark where the distance A was measured. Right? So I'm subtracting 50 from 90. Then again I have to subtract 23.1. Why? Because that is the distance of A. Look at the table, you'll find a 23.1 there.
Yes, miss.
Fine. So it's clear for you now, right? Got it. Good.
Yes, miss.
Now you come to the table, come to the graph. By using the table, you are supposed to draw a graph. And they mentioned that you don't need to start from the origin. And if you just look at the values that they provided, it is kind of, okay, do one thing. In the y-axis, you can start from 0. Okay, guys, in y-axis, start from 0. And then you go for 10, 20, 15. 15 square equals to 0.5 you put. Because as we have a bindings that we have to use the maximum portion of the graph. So for that, we need to graduate this graph in this position. So in the y-axis, do one thing. After 15 square, put it 0.5. Then again 15 square 1. Again 15 square 1.5. Okay, then 5 square will be left alone. Leave it, no problem. Got it? Okay. In the x-axis, we are supposed to take a by b, isn't it? So as we are not bound to start from the 0, so let's start with 0.4 because our first value is 0.455. Okay. In the x-axis, you start from 0.4. Then after 10 square 0.6. Then again increase 10 square 0.8, 1, 1.2, 1.4, 1.6. So the last one will come out as 1.6. Okay, guys?
Yes, miss.
Okay. Now do one thing. Since you cannot draw it right now, you'll do it afterwards. But after that, you can see they told us to find out the gradient G. Roughly, you write down, you will get the gradient around 0.75778 something. Roughly, that will be the gradient. Okay. Now you check part D of the question. They say this gradient will be numerically equal to the weight W of the meter rule.
So it's the same as 0.7.
Yes,
That's
but
it.
Yes, but you have to mention the unit. The
Newton.
Newton. Very good. Newton. After that, look at the last part of the question, that is E. The student has assumed that the center of mass of the meter rule is at 50 centimeter mark. Explain briefly how you would find as accurately as possible the position of the center of mass of the meter rule. No extra apparatus or meters are available. What we can do so that we can ensure that the center of mass is at the 50 centimeter mark. Do you remember we discussed this point before as well? That we can just...
Like the scale should topple in one side and then the other side?
Yeah, that can be done, or we can just place it, try to balance it without any load. Means we'll not put any load, but we just try to balance, means make it horizontal to the table. At a certain point, if you place the pivot, it has to be horizontal to the table. Then we can be sure that that point is our actually nothing but the center of mass. So write down the answer.
But then, miss, if we add the load, then it will topple. Then what's the use?
No. It is that you're finding out the center of mass. It has to be toppled. Okay. So write down, balance the meter rule on the pivot without any load. That point is very important.
Balance the rule on the pivot
without any load and find the center of mass at balance point. And find the center of mass at balance point. Wherever it will be balanced, that will be our center of mass. Okay?
Done, miss.
Okay. Now go to the last point. Question number 8 of this particular question. Explain, briefly state the main difficulty that you would have when carrying out this experiment of balancing experiment. Carrying out this
Obviously
type of
balancing the rule.
Yes, as well you can say difficulty in finding or difficulty in locating or finding the stable balance position of the rule.
In locating
the stable balance position of the rule on the pivot.
Position
of the rule
on the pivot.
Yes.
Okay.
Now let's go to question number 2. Okay. Now let's just have a look. What is the planning question? Okay, there's the planning question. First, let's go for number 2. How do we take the question? Current electricity. Okay. They gave us 2 diagrams for a voltmeter and manometer. You have to write down the readings. Okay, what's the reading?
It's 2.5 in the voltmeter and 0.3.
Yes.
0.3 ampere.
Yeah, correct. But do mention the unit, volt, and ampere. Otherwise, one might be deducted. Okay. Now, R1, you can just calculate and find it out by using the value of V1 and R1.
8.3.
Okay. 8.3. Okay. Now, turn the page, go to part B of the question. Okay. Check. They have given us V2 and I2. By using those two, we can find out R2.
Yes.
14.4.
So,
No, sorry, 11.4.
yeah, that is correct. 11.4. Fine. Now come to C quickly. I want to finish this question in today's class. Okay. Then she did the practical with the 3 lamps and they got the 3 values, V equals to I1 and R1. So they're asking, we got the R3 here, right? Okay. And we had the R1 before, that was 8.33. And now we got 14. So they say that, they say that in series should be given by the equation R3 equals to R1, right? They said it like that. State whether the result agree with this suggestion. Justify your answer by reference to the result. Now, first you do one thing. 3R1. Multiply R1, the value that we found 8.33, multiply by 3 and check what's the answer coming out.
Around 25 ohm.
Yes. This actually 24.99 something came out. We can consider that one as 25. And the difference you find out now, 25 and here R3 is given 14.1 only. So when you subtract, you got around 10.9 ohm. Isn't it?
Yes, miss.
Yeah.
Yes,
and it's a huge number. So our statement will be no. And the justification, R3 equals to 14.1 ohm and 3R1 equals to 25 ohm. Difference is
14.1 ohm.
and 3R1 equals to 25 ohm. Difference is 10 ohm, which is large and beyond the limit of experimental accuracy.
Miss, I'm sorry, it's 4.1 ohm and R31 is 25 point?
Only 25.
25 ohm, okay.
And the difference came out around 10.9 ohm, which is large and beyond the limit of experimental accuracy. Okay, done. Now in part D, we have to draw a circuit. There we are supposed to have 3 lamps in parallel. The voltmeter connected to measure the potential difference across the lamp. Okay, a common voltmeter among them.
Miss,
Yes, dear.
Miss, if you don't mind, can you repeat the justification again?
Okay, quickly. R3 equals to 14.1 ohm. That one I wrote from the first sheet.
Yes.
And 3R1, if you multiply, you will get 25 ohm.
25 ohm.
And difference is 10.9 ohm.
10.9.
Which is large and beyond the limit of experimental accuracy. Okay. Now, girls, the last one, D, they said a variable resistor should be there to control the current in all 3 lamps. Where will you put the variable resistor?
In parallel.
In series.
Series.
Yes. From the power supply, you can go for the variable resistor. Then it will go for the 3 parallel lamps. And voltmeter will also be parallel with the lamps. Okay? Okay, fine, done. So, inshallah, if you have doubt, later we'll do it again. But next week, I want to go for paper 4. Okay, 2019, paper 4.
Miss,
Yes, dear?
Miss, Miss, is it possible that you can note down some common points from paper 6? For example, precaution for some questions.
Yeah, we can do that.
We have the
we can do that.
have the similar always,
Yes,
so
very
some
similar.
precautions and some special questions that
Yeah,
always
we can do
come.
that. Okay, Nureen, do one thing. You give me a message personally in my WhatsApp ID, huh? Then I can do it for you. Okay?
Miss, give it for everyone.
Yeah, already.
Yes.
First of all, let me
Miss,
make
give
it
it for
down.
everyone.
Okay, fine.
Miss, we can make a physics group if you don't mind. Like, and then there you can
Do
send.
you need that here? Here we are meeting all of us together. Okay, fine. I'll give it to you over here. Just wait. I'll give it to you, inshallah. Let me sort it out. Okay. Let us conclude our class today.
Miss.
Yes, dear. Aliyah, say what happened?
Miss, will you take any tests?
Okay, online test. Okay, I can tell you that you can solve one of the variant and you can give me the feedback. because without that, how can I conduct the test there? Right, it's online, right? Okay, inshallah. Let me finish paper 4 with you in next week. After that, we can have.
So, Miss, next week
Yeah,
is
okay, Miss.
19 May, June
Yes.
6,
All
4-1.
the variants, 41, 42, 43, all you keep it with you, and then we can go ahead with it. Okay.
Okay.
Thank you, girls. Allah
Thank you,
Hafiz.
Miss.
Stay safe.
Assalamualaikum.
Wa alaikum salam.
Assalamualaikum. Have a nice day.
You too.